tutorial is going to cover the ambiguous case of sines. This is going to be basically when you're given a triangle, you're given two sides and an angle in that order, or an angle and two sides. The problem with this is that by the name, it's ambiguous. I'm not sure if it has two sides, or if it are two solutions, or one solution, or no solutions at all. Judging from what they give me, if they tell me, oh, it's a triangle, it has this for an angle, it has these two sides, and you look like, for example, the red triangle on the screen, that looks like it could be a regular triangle. It might simply be that one, or there could be two different ones. The problem is, I don't know how long this side is, and I don't know how big that angle is. So I'm not sure how that weighs out. And so the way we're going to tackle this is that we're just going to solve it like normal. We're going to work it out, like you can see here. I've worked it with the law of sines, plugged in the values that I had. I'm looking to find sine of C to find angle C. And you can see that we've done that here. We used sine inverse of 0.4 to get 23.58 equals approximately 24 degrees. And anybody that has watched the other video or has been in class knows exactly how that happened. Now here's the new part. The question is this the only answer, or is there another one? So we're guaranteed to have one answer because this worked. Okay? And you can see down here, I've highlighted in red the parts that they were given to us. Alright? So this is our initial conditions, and over here I've got B prime, lowercase b prime, and C prime. So these are the possibilities of an alternate triangle. Right? What they've given to us is absolute fact, and it's true for both triangles, but we're not sure about the rest of it. So this is the way that you try to find another angle. So they've given me, or we found angle 24. That's obvious. So if angle 24 goes here, then I'm going to go directly to the other triangle. This is my link, and I'm going to do this right here, 180 minus that angle to get my new angle. Now, the letter is irrelevant. It could be B or C or A. It doesn't matter. But whatever angle you find first, you're going to say 180 minus that angle, and it's going to give you the possibility of another one. And here's the test. I'm going to take that angle. In this case, it's 156, and I'm going to add it to the angle that they've already given me. In this case, they gave us A, which was 30 degrees. You should already, once you see that sum, you should already have a problem with that. Right? If we add all the sides of a triangle, they should add up to 180. Well, guess what? We've added only two of the sides, and we got 186, and that's obviously way too big because it's more than 180, and I haven't even added in the third angle yet. So it's not possible. By that judgment, we can conclude that there is only one solution for this set of numbers. So this one will work out normal. Now, what happens in other situations? We're going to explore two other scenarios. Example 2 is using the purple triangle. This one we have basically the same setup. I've got an angle, angle A, side length 16, and side length 7. It's an angle, side, side. Here again, I don't know these two different groupings. And so we're going to solve it in exactly the same way as we did before. So I plug it into the law of sines, just like before. I work it out, and it gives me sine of C equals, and all that simplifies to basically 1.1428. But instantly, you know there's a problem, because when you do sine inverse of that number, your calculator gives you an error, domain, or error just period. Because why? It's because we can never, ever have a number bigger than 1 or less than -1 inside sine inverse. So before I even attempted this, when I got sine of C equals a number bigger than 1, I automatically knew that there was going to be no solution. You know, and even if you forget that, when you do sine inverse of that number, it's going to give you error because it's not possible. And so this is the kind of triangle where there is actually no solution. The third example is the one where we have the biggest issues. Save the best for last. Okay. Notice that every time, and you can look back at the triangles, notice every time it's the differences in the side lengths that are going to make all the difference in the world. Here we have angle of 30, just like before, but now my B is 16 and my A is 10. We're going to approach this one just as before. And we work it out. We see 10 times sine of B equals 16 sine of 30. Work it out, and you get sine of B equals 0.8. At least we know there's going to be at least one solution now. We do sine inverse of that value, and you get 53.13. So we'll round that down to 53 degrees just for the tutorial's sake. Let's check. Remember, we're going to say 180 minus the angle we found. That gives me 127. So here's where we go. We're going to go over to our little charts. So I've got inside the chart all the given answers that they told me last time. I put in my 53 degrees for the angle that we found, and then I put in the 127. The question is, and you can already see, if I add these two together, 30 plus 27, 127 is definitely less. It's only 157. Automatically, because that number is less than 180, we have two triangles. You see that right here. Two triangles are possible. So I go ahead and subtract that from 180 to find C prime. I do the exact same thing over here to find the original C. The only thing left is to find the missing side length for C, and of course we complete that one just like we've always done. We set up our law of sines, and I set them up simultaneously here, and I've solved for C, and so C equals 19.85. Notice that's the largest side, which is across from the largest angle. Over here, C prime turns out to be 7.8. I look up, 7.8 is this the shortest side? Is that the smallest angle? Absolutely. All right, I've put those pictures in there for you. So the original triangle looks like this. The new triangle, the other triangle that we weren't really aware of, looks like this. They've got them backwards from originally. The 30 degrees was on the left side. Now they've got it on the right side. I don't know why they did that, but here are the two different triangles that have they have a 30, a 10, and a 16 in both of them. And this is why we have an ambiguous case, because there's a possibility that my triangles might not look like what they've got drawn on the page. All right? Recap. There is a possibility of two triangles like this. The way we check, we say 180 minus the angle we find. And if we take that value and we add that, way over here, for B prime, we add that number to the original angle. If that number is less than 180 degrees, then there exists a second triangle. I'll plug in my 127 here, and then I've got two different scenarios, and I'll just solve them like I would solve any other triangle. Okay, going back, if we have a sine of C equals a number bigger than 1 or less than -1, automatically we know that there's no solution, because I'm not even going to get an answer out of my calculator for the first triangle. Back again, when there's only one solution, when I get my C prime or my B prime, whatever angle it is, I'm going to add that to the original angle, and that angle is going to be greater than or equal to 180 degrees. If that happens, no second triangle is possible, and you're only left with the one solution. All right, now I've kind of detailed that out over here in this little diagram. I suggest you definitely review that. Not that you have to know all the different details, but that's kind of what it is. Let me call your attention to case 2. Case 2 I'm not really going to discuss because it's not really ambiguous. It's going to work, you're going to get an answer out and it'll work out great, or you're going to get an error just like we did last time, where there is no second triangle. So I'm not so worried about that one, because you guys can work out the law of sines, and if it gives you an answer, boom, you got it. If not, and the way the second case is when the angle they give me, like this, they gave me 30. The second angle is actually going to be, it's going to be obtuse. All right, so no big deal with that one. Make sure you go back through this. If you haven't printed out this page, I totally recommend you print it out and put it in your notes, especially for this chart over here. It's pretty nice. Nicely separated. It's kind of like that in your book too. Check this out. Rewatch it if you need to. Make sure that you have the process down. That's going to be the best part when you bring it into class.